talked about how we can involve inverse trig to find direction, and also Pythagorean theorem to find the distance. And we saw that with vectors. We saw it with polar coordinates. And we can also use right triangle trig to find missing side of a right triangle. Okay. The bottom half here, we talked about how we can graph any point on a complex coordinate plane, okay, with a real component and imaginary component. Whatever is the doesn't have the I next to it, that's going to be part of your x value, and then your imaginary is whatever is attached to I. We talked about how if we want to find the absolute value of a complex number, it's also same idea as finding the distance. So imagine that you're just finding the hypotenuse of a right triangle. So we also call it the modulus. The modulus is basically just the distance from the origin, and we use Pythagorean theorem. Okay. We're going to do a check-in quiz tomorrow. Check-in quiz will just be 4 problems. I'm going to tell you exactly the type of problem you're going to see. One of them is this. So I'm going to have you guys highlight this. We'll go over 1 and 2 just to make sure that you're good with it. Okay. So remember, the first thing you do is you graph each number. So for number 1 here, you're graphing that number. Treat A8 like the x value. Treat -1 as the y value. So you're just going 8 over and down 1. And then just basically pretend like you're just finding the hypotenuse of that right triangle. Okay? And that's going to be your modulus. So Pythagorean theorem, square root of a squared plus b squared. We did go over this yesterday, right? I just want to just kind of review through those steps. Number 2, if you wanted to graph that onto a complex plane, you just go 3 to the left, 6 up, and then the modulus is just going to be that distance from the origin to that point, and just use Pythagorean theorem to get to that. So absolute value of -3 plus 6i is the square root of 3 squared plus 6 squared. I left the negatives out of it because I knew that everything inside this inside the Pythagorean theorem is just going to become positive. So root 45 or 3 root 5. Okay, so you'll see one of those questions on the check-in quiz. Okay, so I just want to make sure that you're comfortable with them. So tomorrow, beginning of class, we'll do the quick check-in quiz, and then we'll move on to the next section. But I just want to tell you exactly what to expect, so there's no surprises. Okay, so let's go to page 14. We did not do this page, right? Okay. I'm going to have you guys copy down a few things here. Distance formula is basically Pythagorean theorem, right? So it's a square root of a sub 2 minus a sub 1 squared plus b sub 2 minus b sub 1 squared. We're not going to find distance for ordered pairs. We're going to find distance of complex numbers, which is going to feel very similar, but we're going to do it in a certain way here. So the formula for the distance between 2 complex numbers is going to be the absolute value of z sub 1 minus z sub 2. And what we're going to do there is we're going to subtract the real number portion together. Or sorry, yeah, we'll subtract the real number portion, and then we'll also subtract the imaginary or complex portion together. Okay, so I'm going to walk you through those steps. Give you guys a chance to copy that down first. Okay, but I'm going to have us split this into individual parts. Okay, everybody good so far? Okay, so here's the example we're going to do here. So example says, find the distance between the two complex numbers. Okay, so we're going to be subtracting, oh, sorry, I had z sub 1 minus z sub 2. Okay. Actually, it's really not going to matter, okay? But yeah, let's just be consistent here, z sub 1 minus z sub 2. Find the distance between the two complex numbers. So we're going to be subtracting the 2, but we're going to subtract the real component, and then we'll also subtract the imaginary component. So we'll do 5 minus negative 1. And then we'll also do the same thing with the imaginary component. So negative 3 minus a negative 8. And so we're left with what? 5 minus negative 1 is 6, and this gives us negative 3 minus negative 8 is 5. Okay, so we're left with 6 plus 5i. So once we're here, then this feels just like the previous page. Okay, we're just going to find the modulus. We're just going to find the distance from the origin. Okay. Now that we've created z sub 1 minus z sub 2, we can just do Pythagorean theorem to find that distance. Okay, any questions there? Okay, try the next one. All right, subtract z sub 1 minus z sub 2. Subtract the like terms, and then get it into the absolute value form, and then just go through the Pythagorean theorem. Okay, so you'll see one of these problems on the Checkin Quiz tomorrow. Okay, subtract the real component, subtract the imaginary component. Okay, so what do we get? Yeah. So once you're here, you know what to do, Pythagorean theorem to get to that distance. Okay, either is fine. Okay, question with distance. Okay, let's review a little bit about midpoint. If I want to find the midpoint of two values, I'm just going to be adding and dividing by 2, right? Imagine finding the average of two values. If I want to find the average of two numbers, I add together and divide by 2. So this is midpoint formula for normal order pairs. Okay. I'm going to be adding the x's together, finding the average between those two. Sorry, I should close the parentheses later here. So basically, I want to find the average of the x values, and then I also want to find the average of the y values. Okay, so we're going to make a slight way to adapt involving midpoint between two complex numbers. So here's the formula. Midpoint for complex numbers is we're going to be adding the like components together and then dividing by 2. So distance formula, we're subtracting the like terms together. Midpoint, we're adding the like terms together and then dividing by 2. Okay, let me show you what that looks like. Find the midpoint between two complex numbers. So I want to find the midpoint between z1 and z2. I'm going to be adding the like terms together and dividing each by 2. So I'm going to add the like terms together. So the 5 and the -1 goes together. When I mean add, that just means you're just going to combine whatever signs you see. You're not going to insert an extra negative into the process. So 5 minus 1. Okay, so that's the real number component of it. And then the imaginary, whatever sign they give you, I'm just going to put them together. So they're both negative, so I'll say -3 and -8. So I found the average of the real component, I found the average of the imaginary component, and whatever I get in return is going to be the midpoint between the two complex numbers. So this is where we stop. We're not going to do anything with distance formula. We're just adding and dividing by 2. We could clean this up a little bit here. 4 over 2 is the same thing as what? 2. And you stop here. You're not going to go any further than this. Okay. Try number 4. Find the average, find the midpoint between the two complex numbers. And this is the third problem that you're going to see on the check-in quiz tomorrow. Okay, try number 4. So add the real components together, divide by 2. Add the imaginary components together, divided by 2. Okay, any questions there? Okay, thank you. Okay, there's one more topic I want to go over, and then we'll go back and we'll review each of the types. Okay, so if you guys can turn to page 16. Everybody good so far? Okay, page 16. adding and subtracting complex numbers geometrically. I think you'll find this pretty easy because we've seen it from the vector unit. We're just adapting it to complex numbers. So we're going to do this both algebraically and geometrically, and you'll have to do one of these on the check-in quiz tomorrow. So this is the fourth problem that you're going to see. Okay, sorry. So algebraically first, recall that complex numbers take the form of a plus bi. When adding or subtracting complex numbers algebraically, the real parts are added together or subtracted depending on whatever sign they give you, and then the imaginary parts are added together, subtracted, similar to combining like terms. Complex numbers can also be added or subtracted geometrically, graphically, by plotting the points and creating vectors with them. Okay. Then we can use geometric vector addition or subtraction. So let's do the algebraic portion first. We're just going to add the like terms together, the real parts together, and then the imaginary parts together. So algebraically, the 5 and 3 can go together, and the 2 and the 6 can go together. Easy enough, right? 8 plus 8i. Okay, so this is how we're going to create this geometrically using vectors. We'll treat this like vector 1, and we'll treat this like vector 2. So vector 1 is 5 plus 2i. So from the origin, we're going to move 5 units to the right and 2 units up, because the real component is going to be along the x, and then the imaginary is going to be vertical. So we'll go 5 to the right, 2 units up. Okay, create your vector there. We can call this vector 1. Now vector 2, we're going to start at the end where we're going to pick up where we left off, and we're going to go 3 units right and 6 units up. So when we add the two vectors together, we're essentially creating the resultant vector. So the resultant vector is just going to start at where we started and end at the end of the second vector. So see if you can get the resultant vector in component form, count to the right and count up. So how many units can we go to the right and go up to reach that destination of this resultant vector? How many units over? 8. Okay, how many units up? 8. So the same result, right? We're just arriving using a geometric vector. Right. So any questions? So this is one that you're going to see on so this is the fourth one you're going to see on the check-in quiz. So a modulus using just finding distance, distance formula, midpoint, and then adding and subtracting complex numbers algebraically and geometrically. Okay, try number 2. Do it the easy way algebraically, and then draw the two vectors connected and convince ourselves that we're getting the same resultant vector. Okay, once you get done with 2, go ahead and finish off 3 and 4. Number 3, you're subtracting vectors, but you can easily make it into an addition problem. You can do plus. I can make this 5 minus I plus -6 plus 5. All right, I can distribute the negative through and then just think of it as adding 2 vectors together. Oh, positive. That's it. Okay, any issues with being able to be comfortable with this tomorrow when you see it? Okay. Okay, so here's our classwork. Let's do all of page 15, and then we'll just do 1 and 2 on page 17. Okay, so I just want us to get enough practice so that tomorrow we'll come in, do the practice, do the check-in quiz, and we can move on to the next section. Okay, so should go pretty quick and also get you guys a chance to get comfortable with each type of problem. Okay, so classwork, page 15, 1 through 12 all, and then page 17, 1 and 2. Okay, and I'll work through the same time you guys are working through. Okay, does anybody still need to look at 1 through 4?
Just roll up a little bit.
Yeah. Further up?
Yeah.
Okay. Okay, are we good with 1 and 2?
Could you check my math?
Okay. Okay, thank you.
All right.
Just be careful with number 7. There's the real portion is missing is what? What's another way of writing 6i? Not 1, but 0. 0 plus 6i. Okay. And that can help you see the 0 minus 3. That's going to be part of the subtraction there. Okay, I'll take it. Thank you. Remember, with distance, you're subtracting, okay? But midpoint, you're adding. Or in other words, in distance, you're introducing another negative into the operation. Midpoint, you're just taking whatever the operation they have and just merging them. And then page 17, number 1 and 2. Number 2 might be a little off the grid, but just try your best there. Okay, is anybody still looking at page 16? Okay, I didn't do any ones involving minus, but if you see a minus in between, you can distribute the negative through and just turn it into a sum of two vectors, two complex numbers. Okay, so beginning of class tomorrow, we'll just look over our notes for a few minutes. I'll give you guys the check-in quiz, and we can move on to the next section. Okay, all right, let me come around and just check your two page. Actually, I want to check 14 through 17. Okay, 14, 15, 16, 17. Vector 2, you're going to go, from here, you're going to go negative 10 times. So then I create a vector that will start here. And this resultant vector equals 5. Guys, no help session tomorrow. I'm hoping that this will be easy. We'll just have you guys review beginning of class, and we should be fine.